Namaskar. I am Anshu Bharaadwaj, Principal Scientist working in the Division of Computer Application, IASRI, New Delhi. Today we will be talking on Introduction to Machine Learning. So what is machine learning? Arthur Samuel, an early American leader in the field of computer gaming and artificial intelligence, he coined the term machine learning in 1959 while he was working at IBM. So what did he say? He said the field of study that gives computers the ability to learn without being explicitly programmed. He termed machine learning and defined it in this way. Another definition that was given for machine learning is that it is programming computers to optimize a performance criteria using example data or past experience. The important term is the past experience. We have a model defined up to some parameters, and learning is the execution of a computer program to optimize the parameters of that model, which uses the training data or our past experience. The model may be predictive to make predictions in the future or descriptive to gain knowledge from data or both. One more definition tells that machine learning is the field of study known as machine learning is concerned with the question of how to construct computer programs that automatically improve with experience. So here we can see 2 or 3 definitions which more or less tells what machine learning is. So let us go with a little bit of history of machine learning. The history roots back to the year 1959, or we say that 1960s, when Arthur Samuel, who invented a program that calculates the winning probability in checkers for each side. So he started this and he only coined the term machine learning. Well, the evolution of machine learning through decades started with the question, can machines think? It is a very, very weird question if we ask or if we see in 1960s. But today we all know that what machine means. Machine means our computers. So the question that can machine think led to the definition of machine learning, led to the birth of machine learning. Then came the rise of neural networks. It was between 1960s and 70s, and we all know that they are very, very popular these days. But machine learning, or ML as we call it, continued to advance through statistical methods such as Bayesian networks and decision tree learning. Later, the revolution of deep learning started off in 2010s with the evolution of the tasks such as natural language processing, convolution neural networks, and speech recognition. These tasks were important in this era, so they led to the birth of deep learning. Today, machine learning has turned out to be a revolutionizing technology that has become a part of all fields, ranging from healthcare to finance and transportation. Anything that starts has some objectives. So we will see what are the objectives of machine learning and with what aims and objectives it was started. So the first thing that comes to our mind when we talk of machine learning is that to design efficient, accurate, and general learning algorithms. How and why? To deal with large-scale problems and to make accurate predictions with respect to the unseen examples or the unseen data points, to handle a variety of different learning problems, to answer theoretical questions like what can be learned, under what conditions it can be learned. And the last, to know how well can it be learned computationally. We have been talking of machine learning since last 3-4 slides, but now we have to understand what exactly learning means. A computer program is set to learn from experience E with respect to some class of tasks T and performance measure P. If its performance at task T as measured by P improves with experience E, that means it is learning. A computer program which learns from experience is called machine learning program, because here machine means the computer, or simply a learning program. Such a program is sometimes also referred to as a learner. So machine learning basically learns from past experience or the past data, or at some point of time we can call that data as historical data. Let us see some examples. The first important example which can tell what learning means is handwriting recognition learning problem. Here we can see that the task T is recognizing and classifying handwritten words within images. The performance is the percent of words correctly classified, and the training experience E is a data set of handwritten words with given classifications. So if we understand this example, we can understand what machine learning means or what learning means. If we do this task using a computer, then it becomes machine learning. Second example is another interesting one, a robot driving learning problem. We all know robots have been used extensively nowadays. So the task can be driving on highways using vision truck sensors. And the performance will be measured as average distance traveled before an error. The training experience means a sequence of images and steering commands recorded while observing a human driver. So all these training experience or historical data, as we can call it, is a sequence of images and steering commands which are recorded while observing a human driver. And using this, the robot will drive on highways using vision sensors, and its performance will be measured when an average distance traveled before an error is calculated. Another problem is a chess learning problem. The task is playing chess. Performance measure is percent of game won against opponents. And the training experience is playing practice games against itself. So we all know computers are playing chess and people are practicing with them nowadays. When we talk of machine learning algorithms, we may see that there's a difference between traditional programming and machine learning algorithms. So let us see the difference between machine learning algorithms and traditional programming. So they depend upon how they are programmed to handle different tasks. So some comparisons on different criteria are given below. Like if we see problem solving approach, then the ML algorithms, the computer learns from training a model on large data sets. Traditional programming, the explicit rules are given to the computer to follow in the form of code that is manually programmed. And likewise, on different criteria like data, complexity of problem, flexibility, and outcome, machine learning algorithms and traditional programming algorithm differ from each other. Like for example, for data, ML algorithms heavily rely on these data, and it defines the performance of the model. At times, we call them as data-dependent algorithms. Whereas traditional programming, they rely on data but less amount of data, as their output depends on the logic which is encoded while programming. Complexity of problems, yes, ML programs are best suited from complex problems like image segmentation, natural language processing, which may require identifying patterns or relationships in the data. In traditional programming, they are best suited with the problem which can be defined using the logic. ML algorithms are flexible, they adapt to different scenarios, especially because the model is restrained with new data. Whereas traditional programming has limited flexibility, as the changes should be done manually. The outcome in machine learning is unpredictable, as it depends on data train, model, and different type of other things. Traditional programming, the outcome can be accurately predicted if the problem and logic are known, because they are very concretely designed when the logic is programmed. Why do we need this? We need this because it is able to learn, train from data, and solve or predict complex solutions which cannot be done with traditional programming. It also enables us to have better decision making, then solve the complex business problems in optimized time. So this is a very, very important thing, that the time is optimized while we use machine learning. Machine learning has applications in various fields. We can see that in healthcare, finance, education, agriculture, sports, and more. So let's explore some reasons why we think that machine learning has become essential in every field. In solving complex business problems, handling large volumes of data, automatic repetitive tasks. If we can do that, if we have to do certain things, we can use ML. For example, with machine learning, we can automate time consuming and repetitive tasks with better accuracy. Gmail uses, for example, Gmail uses ML to filter out spam emails and ensure your index stay clean and spam free. Customer support chatbots, they can use machine learning to solve frequent occurring problems like checking order status, password resets, etc. Big organizations can use ML to process large amount of data like invoices, to extract historical and current key insights. And while they extract historical and current data, they can again use some other machine learning algorithms for future purposes. Another important thing is personalized user experience, self-improvement in performance. For personalized user experience, we all talk of social media now. So all social media, OTT, e-commerce platforms, they use machine learning to recommend better feed based on user preference or interest. For example, Netflix recommends movies and TV shows based on what you have been watching. E-commerce platforms suggesting products you are likely to buy. Then self-improvement in performance. We can tell that ML models are able to improve themselves based on more data. The more data is fed to them, better and efficiently they work. For example, user behavior and feedback. For example, user assistants like Siri, Alexa, Google Assistant, they continuously improve as they process millions of voice inputs. They adapt to user preferences, understand regional accents better, and handle ambiguous queries more effectively. Similarly, search engines like Google, Bing, and other, they analyze user behavior to refine their ranking algorithms. Self-driving cars are a craze these days. They also use data from millions of miles driven, both in simulation and real-world scenarios, to enhance their decision making. How does machine learning work? Broadly, this machine learning process includes project setup, data preparation, modeling, and deployment. So the figure that is given here demonstrates the common working process of machine learning. We can see that project setup identifies the goal, which is chosen and flexible solution. Then it goes to the data preparation, where data collection, cleaning, feature engineering, splitting the data into training, testing is done. Again, moving to modeling, because here the entire work is done, where you are analyzing or modeling. Like for example, when you set up a machine learning model, the hyperparameter tuning is done, training the model, making prediction, accessing the model, and then looking into the performance of the model. Finally, when we are done with this, the model is deployed. That comes in deployment. So deploying this model and then monitoring it and performance, monitoring the model performance and improving the model after evaluating it. There's a detailed sequential process of machine learning, which includes some set of steps or phases, as we can call it. Like for example, we can see that there are 7 circles here, which are showing the stages of machine learning. Starting from data collection, then data pre-processing, choosing the right model, training the model, evaluating the model, hyperparameter tuning and optimization. When we see that there's certain things which are needed in the model, again, then we do the tuning and optimization, and then comes the predictions and deployment. So this is the detail of this. You can go through it. Now comes the classification of machine learning, types of machine learning. Before I talk about on this slide, I would like to tell that basically machine learning tasks, as we call, they can be divided into 2 parts. One is predictive and the other is descriptive. So when we classify machine learning, and as we already seen that what learning means, we can see that it can be classified into four major categories depending upon the nature of learning, signal or response available to a learning system, which are as follows. So the first one is supervised learning, then unsupervised learning, semi-supervised learning, reinforced learning. What is supervised learning? It is a self-explanatory term when we call supervised. That means under certain supervision. So it uses the labeled data sets to train algorithm to classify data or predict outcomes. We can see this figure where there's a set of labeled data. Labeled means there are three types of vegetables and they are labeled. Red color things are tomato, then these orange and green are carrot, and green are bell pepper. So we know that which color and which type of vegetable is named as what name is given to it. So this is a labeled data. Now using this labeled data, my model is getting trained. When it get trained, and when we get new data set or new data point comes or new vegetable is given to us, this model will predict which one is this. For example, if it is an orange green, it will be carrot. If it is only green, it will be bell pepper. And if it is red, it will be tomato. So this will be the output. And this was the text data that we had fed to the model. That means the model understood, or with the experience of this data set, it understood and it got to predict this correctly. So as the input data is inputted into the model, for example, it weighs modify until it fits into the model. This process is known as cross-validation, which ensures the model is not overfitted or underfitted. So we can see that under supervised machine learning, the data which is used for training the model is labeled. But here this test data is not labeled, which is the new data or which is the new entry which has to be predicted. Supervised learning helps organizations scale real-world challenges like spam classification in a different folder from our inbox. Different methods for supervised learning include neural networks, naive-based classifier, linear regression, logistic regression, random forest, and support vector machines. So these are the methods which are used for supervised learning. This is another example which is given here. Let us see, consider the following data regarding patients entering a clinic. The data consists of gender and age of the patients, and each patient is labeled as healthy or sick. So we can see that there are two variables which are explanatory variables which are explaining about this data set, and this one is the class or the label variable. So when we see a male, gender is male, age is 48, he is sick. A female, age 53, is healthy. So on the basis of these two variables which are explanatory, the data will be predicted if there is some new data coming. Let us say some male with age 67 again comes, he will be put in the label as sick. The next thing is unsupervised machine learning. So unsupervised machine learning is opposite to the supervised machine learning, where we had labels in our data. Here we will not have labels, but again we have to go ahead and do the analysis or classify or cluster or group these data sets. So in this we have we do analysis and cluster the unlabeled data sets using machine learning algorithms or different models. The algorithms find hidden patterns or data grouping without human interactions. So we can see here in this figure that these are the data points. There are three colors, blue, orange, and green. There is an unsupervised machine learning or model which is running here, and it is grouping them on the basis of colors. So there is no interference of human or any other thing. The data is not labeled. We do not know where it has to go, Based on this model which is running, it will group them according to their different characters, in this case color. So this method is useful for exploratory data analysis, cross-selling, consumer segmentation, and image and pattern recognition. So it also reduces model features through dimensionality reduction using prominent methods of principal component analysis, singular value decomposition, neural networks, k-means clustering, probabilistic clustering. There are some popular methods of unsupervised learning. Next comes the semi-supervised learning. Semi means it is some way supervised, in other way not supervised. So at its names, it's an integration of supervised and unsupervised learning. This method uses both labeled and unlabeled data to train ML models for classification and regression tasks. Semi-supervised learning is a best practice to utilize to solve the problem where a user doesn't have enough labeled data for a supervised learning algorithm. So in the real world, it's not always possible to have all the data which is labeled. We may have some data which is not labeled. So how we can do it? Integration of these two kinds of models, then we can move ahead with semi-supervised learning. So we can see there that this is a data which is the input data, partially labeled, and the other is not labeled. Now semi-supervised learning, here you are using all the kind of data and the unlabeled data is also there. Now when the unlabeled data is coming here, these input data partially labeled will ask the model to predict this unlabeled data as tomato. So it is an appropriate method to solve the problem where data is partially labeled or unlabeled. It uses self-training, co-training and graph-based labeling. They are some of the popular semi-supervised learning methods. Last comes the reinforcement machine learning. We all know reinforcement mean. What does it mean? So it is a type of machine learning model which is similar to supervised learning but does not use sample data. If you remember, in the supervised learning, we were using a sample data which was labeled, but here we do not use sample data to train the algorithm. This model learns by trial and error. It is somewhat the way human child learns. So you can see that it is an environment and this is a state, it's the agent, and this is the reward when he gets when he tries to train the model. So it is a series of good results will be reinforced to create the optimal proposal or policy for a specific problem. Now comes the supervised learning tasks and algorithms. Task means what all is done under supervised learning and how they are taken care of. So they are generally categorized into two main types. For example, classification, where the goal is to predict discrete labels or categories. And the other is regression, where the aim is to predict continuous numerical values. There are many algorithms which are used in supervised learning, each suited to different types of problems and the availability of the data. Some of the most common ones are linear regression, logistic regression, naive-Bayes algorithms, decision tree, random forest, support vector machine, artificial neural network. These are small description of all these techniques, or we call it algorithms. The linear regression, we all know that it predicts the numerical values using linear relationship between the variables. For example, linear regression is used to forecast housing prices based on past data in a particular area, or another one is forecasting the weather based on the past weather variables. Logistic regression, it is supervised learning method. It predicts categorical variables such as yes or no, replies to questions. It is suitable for applications such as spam classification, quality control on a production line. Then comes decision tree, which is an induction based technique where we keep on inducing the data points and getting the outputs. They are useful for categorizing data and for regression analysis. It predicts numerical values. A tree structure can be used to illustrate the branching sequence of linked decisions using decision trees. Unlike neural networks, decision trees can be easily validated and audited. We have talked of decision trees, and when we talk of trees, we have to come to the forest. So forest ML predicts a value or category by integrating results from different decision trees. So many decision trees make a random forest. Then comes the most important, artificial neural network. it functions similarly to the human brain, as it is, the terms tell, artificial neural network. So it is artificial neural network because it is imitating the human brain, the way human brain works or thinks or computes. It comprises multiple linked processing modes. Neural networks excel at pattern identification and are used in different applications such as NLP, image recognition, speech recognition, and creating images. ANN, as we call them popularly, they do a lot many things other than these applications. Then comes support vector machines, which are very popular and which are known to be very, very efficient classification technique. In the end, towards the end of this lecture, we will be talking of support vector machines in detail. For unsupervised learning, they are again divided into three categories based on their purpose. For example, the first one is clustering, other one is class association rule mining, and the third is dimensionality reduction. So these are the three tasks and the algorithms. For clustering, we use actually clustering algorithms. They group data points into clusters based on their similarities or differences. So they are divided into multiple types based on methods they use to group data. We have clustering algorithms which are centroid based methods, distribution based methods, connectivity based methods, and density based methods. Dimensionality reduction is another function or another task of unsupervised learning. In this, it is used to simplify data sets by reducing the number of features. Features means variables. At times, variables and features are used interchangeably while retaining the most important information. This is better understood in the way that if we have 10 or 20 or 30 variables, let us say I have 100 variables in a data set, but I can see that most of the variables are not giving much information for the benefit of the analysis. So what I will do, I will use some dimensional reduction technique and reduce the number of variables while looking into and ensuring that the information is not lost. So different techniques are principal component analysis, factor analysis, etc. Then comes association rules. Association rule, as it says, that it is to find some association between variables. Find patterns, which is called association rules, between items in large data sets, typically in market basket analysis. For example, it started with market basket analysis. For example, finding that people who buy bread often buy butter. So there's an association between two variables. It identifies patterns based solely on the frequency of item occurrences and co-occurrences in the data set. And the example of the methods or algorithms are a priori algorithm, Eclat algorithm, FP, frequent pattern growth algorithm, etc. Now comes importance of machine learning. We have seen a lot of things, that how, why, what are the objectives, but the most important thing is that what is the importance of machine learning and why we are reading this lecture or going through this lecture. Machine learning is important in automation. It extracting insights from data and decision-making processes. It has its significance due to the following reasons. First is data processing. The main reason machine learning has become so important is to process and make sense of large amounts of data. Traditional methods of data analysis, they became insufficient given the explosion of digital information coming from social media, sensors, and other sources. So this data is important and reveals hidden patterns and provides invaluable insights for decision-making processes, which can be exploited by machine learning algorithms. The next thing which is important is data-driven insights. So when there is a lot of data, there are patterns which are hidden and we have to find information and knowledge out of them. And ML algorithms, they can find patterns, trends, correlations in big data sets that human cannot see or understand. So better decisions and forecast can be made with this information. Then machine learning also automates manual activities, saving time and decreasing errors by learning from data and improving over time. ML algorithms can perform previously manual tasks, freeing humans to focus on more complex and creative tasks. And this is not only increasing the efficiency, but also opens up new possibilities for innovation. Data entry, classification, and anomaly detection can be automated with machine learning. It also leads to personalization. For example, user preferences and behavior can be analyzed using ML algorithms to generate personalized recommendation and experiences. And I'm very sure that all of you must be experiencing it while surfing or while buying things online or uh, watching TV or watching OTT platform. You must be getting a number of recommendations. So behind all these, there are strong machine learning algorithms which run. It is most widely used in social media, like in e-commerce, streaming services, by providing a way to increase user engagement and satisfaction. In finance, it is used for credit scoring, algorithm trading, and fraud detection. Retail, machine learning can also be used for recommendation systems, supply chains, customer service. An important application is fraud detection and cybersecurity also. It can detect patterns of fraudulent behavior for financial transactions by detecting and mitigating security threats in real time. It is used to enhance cybersecurity as well. For continuous improvement, it is possible to train and update machine learning algorithms with new data at regular intervals. Because in the starting only, I told that machine learning models, they learn on the historical data. More and more data they have, better and efficient predictions they will give. So they improve with the data. And this data enable them to adapt to changes in the environment as well as improve over time. So we all can say that machine learning enables organizations to take advantage of the power of data to gain insight, streamline processes, and drive innovation throughout a variety of sectors. Applications. The most prominent applications today are speech recognition, also known as automatic speech recognition, computer speech recognition, or speech to text, and it is capability that uses natural language processing. And it translates human speech into written format. To perform voice search such as Siri or improve text accessibility, a large number of mobile devices incorporate speech recognition into their systems. Customer services are there. For chatbots, they are replacing human operators on websites and social media, affecting client engagements. Chatbots answers shipping FAQs, offer personalized advice, cross-sell products, and recommend sizes. So, if you are wondering how it happens, it is happening on the basis of a large database which is built over the experience or historical data. Some common examples are virtual agents on e-commerce sites, Slack and Facebook Messenger bots, virtual and voice assistants. Then another thing is computer vision. The AI technology allows computers to derive meaningful information from digital images, videos, and other visual inputs that can be used for appropriate actions. Computer vision powered by convolutional neural networks is used for photo tagging on social media, radiology imaging in health sector, and self-driving cars in the automotive industry. I have already talked of recommendation engines. Robotic process automation is another very important application. It is also known as software robotics. RPA uses intelligent automation technologies to perform repetitive manual tasks. Automated stock trading, people are using it a lot for stock trading in the stock markets. The AI-driven high-frequency trading platforms, they are designed to optimize stock portfolio and make thousands or millions of trades each day without human intervention. Fraud detection, ML is capable of detecting suspected transactions for banks and others in financial sector. A model can be trained by supervised learning based on knowledge of recent fraudulent transactions. Anomaly detection may identify transactions that appear unusual and they need to be followed up. Now, as I said, that we come to the introduction of ML with this, but now I will take you to what is a support vector machine, because I want to take one technique of classification so that we can learn how to do it. So what is a support vector machine? A support vector machine is a supervised machine learning algorithm. Supervised machine learning algorithm we have just seen in the previous slides. It classifies data by finding an optimal line or hyperplane that maximizes the distance between each class in an n-dimensional space. It may sound a little complex right now, but as we move in the other slides, you will understand it. So they were first developed in 1960s, but they were refined in 1990s by Vladimir Papnik and his colleagues when they published their work in a paper, Support Vector Method for Functional Approximation, Regression Estimation and Signal Processing in 1995. So it's not that old, but it has come up as a very, very powerful classification algorithm. They're commonly used within classification problems. They distinguish between two classes. So now there can be one question that if we have more than two classes in one data set, how would they work? So then they work for multiple classes also, but that multiple classes, this is a different process how a support vector machine works. So we will not take it up here. We will just talk of two classes and how do they do it? They distinguish between two classes by finding the optimal hyperplane. What is an optimal hyperplane? I will tell you in the next slide. It maximizes the margin between the closest data points of opposite classes. SVMs are powerful yet flexible supervised machine learning algorithm which is used for both classification and regression. But generally they are used in classification problems. In the starting, when we talked of classification and regression, we saw that classification is done when we have labeled data and regression is done when we are talking of continuous data, prediction of a continuous number. So SVMs have their unique way of implementation as compared to other ML techniques. Nowadays, they are extremely popular because of their ability to handle multiple continuous and categorical variables. How does an SVM work? The goal is to find a hyperplane that separates the data points into different classes. A hyperplane is a line in two-dimensional space, a plane in three-dimensional space, or a higher dimensional space in an n-dimensional space. A hyperplane is chosen in such a way that it maximizes the margin, which is the distance between the hyperplane and the closest data points of each class. The closest data point are called support vectors. So here comes the name support vector machine. It's not a machine, it's an algorithm. How do we see and how do we calculate the distance between hyperplane and data point? It is known to be x and can be calculated using the formula given below. Distance is equal to w into x plus b by w. So w is the weight vector, b is the bias term, and w is the Euclidean norm of weight vector. So weight vector is perpendicular to the hyperplane and determines its orientation, while the bias term b determines its position. There are a few more things about SVM, that it is widely used in machine learning as it can handle both linear and non-linear classification tasks. We all understand that in real life, it's not necessary that we have certain data points which can be linearly classified, meaning that we can draw a straight line between two classes or two parts of the data. It's not possible in the real world. So SVM is very strong because it can handle both kind of classification tasks. Linear SVMs are used with linearly separable data, which can be divided into two groups using just one straight line. This means that data do not need to undergo any transformation to separate the data into different classes. So this optimum hyperplane is found by solving an optimization problem. Task is to find the hyperplane that maximizes the margin between the two classes while ensuring that no data point is misclassified. And this becomes a convex optimization problem that can be solved using quadratic problem. I'm very sure a little bit of mathematics is to be understood here. However, when the data is not linearly separable, that means we cannot separate the data into two classes using one straight line. Then comes the kernel functions. They are used to transform the data higher dimensional space to enable linear separation. So you transform the data, and this application of kernel function is known as the kernel trick. This trick maps the data points into a higher dimensional space where they can become separable. That means linearly separable. The kernel function computes the inner product between mapped data points without computing the mapping itself. This allows us to work with the data points in the higher dimensional space without incurring the computational cost of mapping them. Choice of kernel functions such as linear kernels, polynomial kernels, radial basis kernels, or sigmoid kernels depend upon the data characteristics and the specific use case. So these are different kernels which can be used for classifying non-linearly separable data. There are few important concepts. We have just talked of them. You can just see this image and understand. Support vector, they are the data points that are closest to the hyperplane and they are known as support vectors. Separating line will be defined with the help of these points. We can see that on x and y axis, we have plotted all the data points that we have. These are two groups, we can see that, but they cannot be separated using a straight line. So what we are trying to do, these are class A, this is class B. These are support vectors because they are closest to the hyperplane. The hyperplane is, this distance is to be maximized so that none of the points is misclassified. This is the margin as we say, and this is the hyperplane. This line is the hyperplane. As we can see in the above this diagram, it is a decision plane of space which is divided between a set of objects having different classes. Now this is the margin which has to be maximized. When we keep on maximizing it, that means the 2 points are clearly classified. May be defined as a gap between two lines on the closest data points of different classes. It can be calculated as a perpendicular distance from the line to the support vector. You can see this. Large margin is considered as a good margin and small margin is considered as a bad margin, because if this margin is less, these 2 points can get mixed up. So they will not be clearly classified. So with this, we come to the end of this lecture. Thank you very much.